Now we will discuss about the speed of transverse wave in a stretched string. So here a transverse pulse is propagating through a stretched string. Let us consider a small portion of pulse or length of the pulse dl is considered. Now the two tensions are acting at the two edges which are acting along the tangential on this pulse. The component of tensions are, one is a T cos, other is the T sin. So here the horizontal components of tension T cos theta, these two gets cancel each other. The vertical components of tension T sin and T sin, these two are add up, which is equivalent to the radial force, which is equivalent to centripetal force. So in this case 2t sin theta, which is acting downward direction, which is equivalent to Fr. This is called centripetal force or radial force, which is acting toward the center. From sector OAB, we have length of the arc L is equivalent to r theta. Using this formula, length of the arc is equivalent to dl over here. OB is what we call radius, r into this complete angle of the sector is equivalent to 2 theta. Now using this relation, 2t sin theta is equivalent to Fr. Fr is nothing but a dm into v square by r, where r is the radius of this arc. Dm is the mass of this elementary particle. Now our aim is to calculate the speed of transverse pulse, which is equivalent to v over here. And for small angles of theta, sin theta can be replaced by theta. So from this one, from this dl is equivalent to r into 2 theta, 2 theta value can be replaced by dl by r. Therefore using this value over here, 2 into theta can be replaced by dl by r. So t into dl by r. Now our aim is to find out the v value. So v square is equivalent to t, r gets cancelled over here, dl by dm, which is equivalent to t by dm by dl. Here dm by dl is nothing but a mass per length, which is represented by mu, which is equivalent to t by mu. Therefore v square is equivalent to t by mu. From this one, v is equivalent to under root of t by mu. Therefore v is equivalent to t by mu is the formula used to calculate speed of transverse pulse propagating through a string, where T is the tension in the string, where mu is the linear mass. Linear mass is nothing but a mass per unit length, which is nothing but total mass by total length. So therefore V is equivalent to root of T by mu can be used to calculate speed of transverse pulse propagating through stretched string. Speed of transverse pulse V is equivalent to T by mu can also be replaced by with other terms. So mu is equivalent to linear mass, mu is equivalent to, that is mass per length, mass is equal to density into volume by length, density into volume can replace by length into area by length, length gets cancelled, rho into A. Therefore mu can replace by A into rho even, and T by A, that is force by area, can also replace with stress. Therefore the other forms of speed of transverse wave is V is equivalent to T by mu, T by A rho under root, stress by rho. Like this the other forms of the speed of transverse pulse. So let us see some applications of speed of transverse pulse. Let us consider this is a string which is passed over a frictionless pulley. It is connected to a load of mass m. It is in air. Now the tension T1, which is equivalent to T1 over here, we want to calculate the speed of transverse pulse propagating through a string. The velocity or speed we want to calculate. Speed V1 is equivalent to under root of T1 by mu. Therefore T1 is equivalent to, here T1 is equivalent to mg, Therefore, T1 can replace by mg, mu is mu. Therefore, in this case, the speed of transverse pulse is V1 is equivalent to root T1 by mu or mg by mu when it is suspended in air. Now, second application, the string is passed over a pulley and load is immersed in a liquid of density sigma. Here, density of the body is equivalent to rho, density of liquid is equivalent to sigma. That means a load is suspended inside the liquid of density sigma. Here what happens to speed of transverse pulse? In this case, the wave is propagating from through a string. We would like to find out the speed of transverse pulse propagating from one end to other end. So here the forces acting on the wire or the string are the weight of the body mg acting downward, mg is equivalent to v rho g, and the tension T2 acting towards fixed point. One force comes into play called buoyancy, which is called upthrust. So the tension T2 acting upward, buoyancy force acting upward in the string, the weight of the block which is acting downward. So here T2 plus Fb is equivalent to weight. The tension T2 is equivalent to weight of the body minus buoyancy force, which is equivalent to mg into 1 minus sigma by rho. Now, we know the general formula to find the speed of transverse pulse is V2 is equivalent to under root of T2 by mu, where T2 is the tension in the string. Therefore, T2 by mu, T2 can replace by mg into 1 minus sigma by rho, and substituting this value over here, we will be getting V2 is equivalent to mg by mu times of 1 minus sigma by rho. As we know, V1 means in air, we got mg by mu. This value can be replaced, mg by mu value can be replaced with V1. Therefore, V2 is equivalent to V1 into 1 minus sigma by rho. That is nothing but a speed of transverse pulse in liquid is equivalent to speed of transverse pulse in air times of 1 minus sigma by rho. So, this is the relation between the speed of transverse pulse in liquid and speed of transverse pulse in air through a string. Suppose V1 be the speed of transverse pulse propagating through a string in air, V2 be the speed of transverse pulse propagating through a string in water, V3 is the speed of transverse pulse propagating through a string in media. Then we know the specific gravity, the various forms of specific gravity. One of the forms of specific gravity is density of the body in air by density of water at 4 degrees centigrade. We know that how this V and T are related, V proportional root T or T proportional V square. Therefore, this value can be replaced by T1 by T1 minus T2, which is also equivalent to V1 square by V1 square plus V2 square. One more formula for specific gravity we have loss of weight of body in liquid by loss of weight of the body in water, which is equivalent to T1 minus T3 by T1 minus T2, which is equivalent to V1 square. T1 can replace by V1 square, T3 can replace by V3 square, T1 and T2 V1 square, V2 square. These are the various forms of the specific gravity in terms of V1, V2, V3. Speed of wave in a vertical string. Let the mass of string is m, total length of string is equal to L, upper end is fixed, lower end is free. Let us consider a transverse pulse is propagating from lower end to upper end. We want to calculate the speed of transverse pulse at a distance of x from the free end or the lower end at a point P. We know the basic formula V is equivalent to under root of T by mu, where T is the tension in the string at P. That how can we calculate? So, we want to find out the tension at P. To find out the tension at P, the mass of the whole string is m, mass per length into length of this part of string is equivalent to x. This is what we call tension at point P. Now, we want to find out the speed. V is equivalent to under root of T value can be replaced by m by L into x by, and mu value is nothing but a mass per length is equivalent to m by L. M by L gets cancelled. So here v is equivalent to under root of gx. I repeat again, we want to find out the speed of transverse pulse at p, which is equivalent to t by mu. The tension at p is nothing but a mass of this part into g. How to find the mass of this part of string? Mass per length into length of this part of string into g. That will use the tension. So v is equivalent to t by mu. This is the part of a tension, and the mu is equal to m by l. These two gets cancelled. V is equal to gx. That means v is equivalent to root gx is the formula to calculate speed of transverse pulse at a distance of x from the free end. Suppose at the lower end you want to calculate, somewhere over here you want to calculate, means at lower end x is equal to 0, so speed is equivalent to 0. At a distance of half of the length, that means at length L by 2, v is equivalent to under root of g into L by 2. Again you want to find the speed at O. Speed at O is v is equivalent to under root of g into L. This is the method to find out the speed of transverse pulse propagating through a string from lower end to upper end in the vertical string. One more application, the transverse pulse is propagating from free end to rigid end. We want to calculate the speed of pulse at a distance of x from lower end, speed of pulse at a distance of x from rigid end. So for that what to do? We have to find out the tension at P, tension at Q. Tension at P due to this part of string, tension at Q due to this part of string. Therefore, tension at P is equivalent to, due to this part of string, tension at point P due to this part of string is nothing but a mass per length into length of this part of string into g. Tension at Q is equivalent to mass per length into length of this part of string, which is equivalent to L minus x into g. Therefore, using these values over here, velocity at P or speed at P is equivalent to root gx from the earlier derivation we come across. Similarly, speed at Q is this part of string we should take into consideration. So, Vq is equal to g into L minus x. So, Vp by Vq is equivalent to, by simplification of this, x by L minus x. So, velocity v is equal to n lambda. So, frequency remains. So, Vp by Vq is equivalent to lambda p by lambda q. And we know that speed is maximum at rigid end, minimum at the free end. Therefore, Vmax by Vmin is equivalent to lambda max by lambda min is equivalent to L minus x by x when you compare the point P and point Q. Now, we want to calculate the acceleration of pulse over a distance L. Suppose the pulse is propagating from lower end to upper end through a length of L. Now, we want to find out the acceleration. See, V square h, using the formula V square minus U square 2as, V square h, V square L 2as. That means Vh, velocity or speed of transverse pulse at the highest point, Vl at the lowest point. We know that over here tension is equal to 0, speed also equivalent to 0. So, this value becomes 0. So, V square h minus 0, 2 into A into L, because the distance travelled by pulse over a length of L. From this one, A is equivalent to V square h by 2L, which is equivalent to GL by 2L, because the speed of transverse pulse over the rigid end is root GL, squaring is GL. So, GL by 2 will become G by 2. Therefore, acceleration of pulse through the string is A is equivalent to G by 2. Let us see one more application. Some load M is added at the lower end of the string and mass M, small m, and length L be the mass and length of the string. We want to calculate the speed of transverse pulse at B at a distance of x, at a point C at a distance of L by 2, at point O at a distance of L. Now, speed at A is root T by mu. That means tension at A by mu. Tension at A is only by this block of mass capital M, which is equivalent to mg by mu. Now, speed at B, the tension at B is due to the block as well as string of part of x. So, m is the mass of the block, mass of this part of string is m by L into x, into g is the tension, linear mass is equivalent to mu. Similarly, speed at c, which is half of the length, therefore, the tension over here is due to block of mass m, is due to string of length L by 2. Therefore, m plus m by L into L by 2, which is equivalent to L gets cancelled, m by 2 into g by mu. Similarly, to find the speed at O, V at O is equivalent to the tension is due to block, due to string. Due to block is mg, due to string is small m into g. The total tension is capital M plus small m into g, linear mass is equivalent to mu. Now, where the velocity is maximum, speed is maximum at O, speed is minimum at A. Therefore, V max by V min is equivalent to capital M plus small m by capital M, because mu gets cancelled. We know that V is equivalent to n lambda, so V max by V min is equal to lambda max by lambda min, since frequencies remains. So here, there is a point P at a distance of x from lower end, there is a point Q at a distance of x from upper end. We want to find out the speed at P and Q. So speed at P and Q is speed at P due to block, due to this part of string, tension taken into consideration. At point P, due to block and this part of string mass, we should take into consideration. Therefore, using the earlier concept, Vp by Vq is equivalent to capital M plus m by L into x by capital M plus m by L minus x. In this case, when a transverse pulse is propagating from lower end to upper end, speed increases, wavelength lambda increases, but frequency remains. Now, let us calculate the time taken by transverse pulse to move from lower end to upper end. In the earlier topic, we come across the speed of transverse pulse at a distance of x from lower end is V is equivalent to root gx. We know that V is equivalent to dx by dt is equivalent to root gx. From this one, this can be replaced or simplified as root dt is equivalent to 1 by root gx into dx. So, root g outside, this root x can be replaced by x power minus 1 by 2 dx. Taking this root g outside, this integration of x power minus 1 by 2 dx. We have one formula, integration of x power n dx is equivalent to x power n plus 1 by n plus 1. Using that formula, integration of x power minus 1 by 2 dx is equivalent to x power minus 1 by 2 plus 1 by minus 1 by 2 plus 1, which is equivalent to root to 2x. Now, the limits of distance is 0 to x and the time limits are from 0 to t. So, therefore, this integration of dt is equivalent to t. On simplification of this, you will be getting 1 by root g, 2 root x will be getting. So, therefore, t is equivalent to 2 under root of x by g. That means, the time taken by transverse pulse to move from lower end, that is the free end to a distance of x is 2 root x by g. Similarly, the total time taken by transverse pulse to move from free end, that is lower end, to the fixed end is 2 root L by g, 2 root L by g seconds. So, before this we discussed, this is a string of mass m, length L. The time taken by transverse pulse to reach upper end from lower end is t is equivalent to 2 under root of L by g. Similarly, when a block of mass m is attached at the lower end of the string, then we want to find out the time taken by transverse pulse to reach fixed end. So, here very simple, speed at A mg by mu, speed at B, in addition to block mass, we should take the mass of string also into consideration using the formula T by mu. Speed at A we discussed earlier, speed at B so and so. Using the formula V is equivalent to U plus AT, V at B, speed at B, V at A, speed at A into T. Earlier we discussed one concept, the acceleration in the string over a distance of L, A is equivalent to G by 2. Using those values of VA, VB and A is equivalent to G by 2, substituting all these three values over here, we can find out the time taken by transverse pulse to reach from lower end to upper end as VB minus VA by A, VB value this much, VA value this much. Here taking root GL outside and g by 2 become 2 by g of root gl into capital M plus small m under root minus capital M root by small m root. So, this is a formula to find out the speed of transverse pulse to reach from lower end to upper end in this case. So far we discussed to find out the speed of transverse pulse through a string of uniform cross sectional wire. There is a string of non-uniform cross section. So, how to find out the speed of transverse pulse propagating through a non-uniform cross sectional? So, let us see one problem. A wave pulse propagating along x axis with a non-uniform wire of length L whose linear mass varies with distance as mu is equal to m naught plus alpha x. Now, we want to find out the time taken by transverse pulse from lower means lighter end to heavier end. That how can we calculate? We know the formula for speed of transverse pulse is V is equivalent to root of t by mu, which general formula dx by dt, and t is equal to t newtons. Mu value he gave as mu is equal to m naught plus alpha x. Now, separating x terms and t terms. So, root t where capital T is the tension, root to t dt is equivalent to under root of m naught plus alpha x into dx. Integrating on both the sides, integration of dt is equivalent to t. Now, integration of n naught plus alpha x. Here m naught plus alpha x power 1 by 2. Just now I told you the formula for integration of x power n dx as x power n plus 1 by n plus 1. Using that basic formula, integration of m naught plus alpha x under root is equivalent to m naught plus alpha x power 1 by 2 plus 1 by 1 by 2 plus 1. Again, the differentiation of m naught plus alpha x must be substituted over here. On doing this, so t is equivalent to this 2 by 3 alpha root t comes over here. Now, substitute upper limit then lower limit. Substituting L over here m naught plus alpha higher power 3 by 2. Substituting 0 over here m naught plus 0 power 3 by 2 is m naught power 3 by 2. So, this is generally used in mains exam. So, this is a formula to find method to find out the time taken by transverse pulse through a non-uniform cross sectional wire of a string. Let us see one problem based upon the concept of speed of transverse pulse. A heavy ball is suspended from a ceiling of a vehicle with a light string, that is, there is a vehicle. So, when the vehicle is at rest, the speed of transverse pulse in the string is 60 centimeters per second. When it is at rest, the tension T1, the string is T1 is equivalent to mg, the speed of transverse pulse is 60 centimeters per second. Now, when this vehicle is going towards right with an acceleration of a, the pseudo force comes into play. Pseudo force means imaginary force. For example, you are inside the car. When the driver takes sudden turn at the corner, you feel that somebody is pushing you outside. You will fall radially outwards. No? Somebody is pushing you outside. The 𝗵𝗏 force is called pseudo force. Similarly, the pseudo force comes into play on the block of mass m, which is acting backward direction. So, mg is acting downward. The resultant of these two, T2 is equivalent to mg square plus ma whole square under root. So, this T2 is taking m outside, g square plus a square under root. In this case, the speed of transverse pulse propagating the string is 66 centimeter per second. And we know V1 by general formula, we have V proportional to root tension, because in both the cases same string we are using, same linear mass, only thing is tension will vary. So, V1 by V2 is equivalent to T1 by T2 under root. So, T1 value in the first case can be replaced by mg, in the second case can replace by m into g square plus a square under root. Now, m gets cancelled, left over is this, and V1 value means when it is at rest, value 60 centimeter per second. When it is going with some acceleration, the speed in transverse pulse is 66. Substituting these values on simplification of this, 60 by 66 whole square is equivalent to, let us take g value as a 10. So, 10 by 10 square plus a square. On simplification of this, you will be getting a is equal to 6.1 meters per second square. This is inclined plane. Over this, the two blocks of masses m1 m2 are tied by means of light string, which is passed over a frictionless pulley. So the linear mass or the linear density, which is mass per length of the string, is given as 9.8 into 10 power minus 3 kilogram per meter. A transverse pulse is propagating through a string with a speed of v is equal to 100 meters per second. The angle of inclination is given as 30 degrees. Now the question is that if the system is in equilibrium, he is asking us to find out the masses of the two bodies. Now if the system is in equilibrium, T is equivalent to m2g, because there are only two forces acting on the block of mass m2. The weight of the block m2, which is equivalent to m2g acting downward, which is balanced by tension in the string. This is equation 1. And the block of m1, the weight of block m1, m1g acting downward, the components of weights are m1g cos, m1g sin. So here normal force is n is balanced by m1g cos and m1g sin balances by tension. Because as the string is in equilibrium, as the system is in equilibrium, this T must be equivalent to m1g sin. T is equivalent to m1g sin 30 degrees. This is equation 2. So in the string is only one, the tension is same. From equation 1 and 2, m2g is equivalent to m1g sin 30 value 1 by 2. This will become 1 by 2. So gg gets cancelled. From this one, m1 is equivalent to 2m2. m1 is equivalent to 2m2. So here from equation 1 and 2, we got the relation between m1 m2 as m1 is equivalent to 2m2. Now we want to find out the m1 m2 values. So he gave in the problem velocity, a speed of transverse pulse is 100 meters per second. V is equivalent to root T by mu. T value can replace by either m2g or m1g by 2. Now I am taking T is equal to m2g by mu. Now m2 is m2, g value 9.8, mu value given the problem is 9.8 10 power minus 3. On simplification, these 9.8, these two gets cancelled. m2 into 10 power 3 is equivalent to 4 zeros. On simplification of this, m2 is equivalent to 10 kg. We know that m1 is equivalent to 2m2. Therefore, m1 is equivalent to 20 kg. So this is how the masses can be calculated. So let us see one more problem. This is the string. Some load is attached over here. Due to this load, the wire elongates. Now our problem is a string of length 2L. That means initial length is equal to 2L, which obeys Hooke's law. It is stretched so that extension is L. Then the velocity is V. I repeat again, when the initial length is 2L, due to extension of L, the speed is equivalent to V. Suppose if it is further stretched so that the total elongation is equivalent to 4L, what would be velocity? So let us see. If it is obeying the Hooke's law, F is equivalent to Kx, and we know the formula for speed of transverse pulse is V is equal to root of T by mu. T is equal to here F, which is equivalent to Kx. Mu means here mass per length. Before extension of length, mu is equivalent to total mass by total length. The length of this is equivalent to L. If it is stretched further by a distance of x, now the mu value become total mass by L plus x. Here mass remains but length changes, also automatically mu also changes. So in the first case, when it is stretched by a length of L, okay, so T by mu, Kx by T value Kx by mu is equivalent to capital M by the final length after extension. From the simplification, we will get x into L plus x into K by M. So due to extension, K value remains, M value remains, only variable is here x. Therefore, V proportional to x in L plus x. So V under root of proportional to under root of x into L plus x. If you want to compare two cases, V1 by V2 is equal. In the first case, length is 2L, extension is L. In the second case, length is 2L, extension is 4L. Therefore, V1 by V2 is equals to actual length is L, actual length is 2L, extension is L. In the second case, actual length is 2L, extension is 4L. Using these values, after simplification of this, we will be getting 1 by 2 root 2. So V2 is equal to 2 root 2 times of initial velocity. These are the strings. The strings are made up of same material, means mu is same, which are having same cross sectional area. That means linear mass is same and as well as the same area of cross section, which are arranged like this with the two pulleys. Now our question is that when a wave is propagating through a string, we want to calculate if the speed of transverse pulse propagating through a string of AB, if it is V1, then the speed of transverse pulse propagating through a string of CD is how much? We know that in this arrangement, the tension T1, which is also T1 over here, this is also T1. So in the string of CD, the tension T2 is equivalent to 2 times of mg. If T2 is equivalent to 2T1, T1 is equal to mg, we know, T2 is equivalent to 2 mg. How the speed and tension are related? V propose root T. We have the formula V is equivalent to root of T by mu, but mu is same, which is given the problem as already. So V proposed root T, V1 by V2 is equivalent to, otherwise VAB by VCD is equivalent to under root of T1 by T2. That is tension in the AB part and T2 is the tension in the CD part. So using these two values over here, we will get 1 by root 2. Therefore, speed of transverse pulse in the string of CD is equivalent to root 2 times of speed of transverse pulse in the string of AB. Yeah, now let us see the concept of sound. What do you mean by sound? How the sound is produced? Sound is produced only from vibrating bodies. Actually, what do you mean by sound? Sound is a form of energy which is produced only from vibrating bodies, which will propagate from one point to another point in the form of longitudinal mechanical waves. So here, these longitudinal waves can propagate through both solids, liquids and gases. I explained you earlier clear concept of what do you mean by longitudinal waves, properties of them and etc. etc. Now, these sound waves, suppose some people can speak, we cannot hear, some people speaks, we can hear, some people speaks, we can hear, but that sound is not clear. So these type of sound waves classified on the basis of the frequency. So the sound waves are classified into 3 categories based upon the frequency. One is called infrasonic, means which we cannot hear, whose frequency limits between 0 to 20 Hz. For example, second one is about the audible or sonic, which we can hear clearly. So those limits of the frequency of the audible or sonic are 20 Hz to 20 kHz. Lower limit is 20 Hz, upper limit is 20 kHz. In the case of ultrasonics, whose frequency is greater than 20 kHz. What do you mean by that? In 1 second, if it is any vibrating body vibrates 20,000 times in 1 second. If it is more than that, we cannot hear. We will hear, but that sound is not clear. So these are the 3 different types of sound waves which are classified on the basis of their frequency. Now let us see the concept of wavelength. Here frequency limits of audibility is 20 Hz to 20 kHz. We know, now we want to find out the wavelength limits of audibility. We know the formula V is equal to n lambda, lambda is equivalent to V by n. When the velocity of sound is 340 meters per second, lambda 1 means lower limit frequency, if it is lower, lambda is equivalent to 340 by 20, which is equal to 17.5 meters. Now for a frequency limit of 20,000 Hz or 20 kHz, the wavelength is lambda 2 is equal to 340 by 20,000, which is equivalent to 17.5 mm. Therefore, wavelength frequency ranges are 20 Hz to 20 kHz for audible or sonic, whereas the wavelength limits are from 17.5 millimeter to 17.5 meter. That is about the wavelength range of the audible or sonic waves. Now let us see speed of longitudinal waves in a medium, means in elastic medium. So according to Newton's equation, speed of sound through gases V is equivalent to P by D. Using this equation, there is a lot of difference between the theoretical value and the practical value, because he assumed that the medium obeys isothermal condition. Later, Laplace made a correction using Newton's equation. He formulated new equation as V is equivalent to under root of gamma P by D. According to his assumption, the media obey the condition of adiabatic. That means under adiabatic condition, V is equivalent to gamma P by D. So, V is equal to P by D is what you call Newton's equation. Laplace modified the Newton's equation, he formulated new equation as gamma P by D. Using this equation, the theoretical value and the practical values almost they are coinciding. So, we will use the formula gamma P by D is used to find the speed of sound through gases. Here, in any elastic medium, basic formula V is equivalent to root of E by D or E by rho, where E is the modulus of elasticity, rho is the density of the medium. We have the various formulae, propagation of these longitudinal waves which has some velocity or speed, the speed of those waves in solids, liquids and gases, because longitudinal mechanical waves can propagate through solids, liquids as well as gases. Through solids, under root of Y by rho, where Y is the Young's modulus, where rho is the density of the medium. Velocity or speed of these waves through liquids is equals to under root of K by rho or K by D, where K is called bulk modulus of liquid or gaseous medium. So, V of gas, speed of waves through gaseous medium is under root of P by rho, where P is the pressure, rho is the density. This is the formula used for Newton's equation. Later modified form is gamma P by rho. So, speed of sound through gases, we use the formula gamma P by rho. The other form of this one is speed of gas through speed of waves, longitudinal waves through gaseous medium is root of gamma P by D. This can also be replaced by gamma RT by M, because from ideal gas equation we know that PV can be replaced by nRT, where P is the pressure, V is the volume, where N is the number of moles which is equivalent to small m by capital M, where R into T, where R is called universal gas constant, T is the absolute temperature. So, these are the various formulae to find out the speed of waves through various media. So, we have the formula V is equivalent to gamma P by D is used to find the speed of sound through gaseous medium. Now, let us see the various effects, effect of pressure, effect of density, effect of humidity, effect of temperature. See, first of all, let us see effect of density. V is equivalent to gamma P by D, where D is the density of the medium, V proportional to 1 by root D. That means, density increases, speed decreases, density decreases, speed increases. From this relation we can say, whenever you want to compare the speed of sound in two different media with two different densities, V1 by V2 is equal under root of D2 by D1. That means, V1 by V2 is D2 by D1, lighter gas, greater will be velocity. Lighter means less denser, more speed. Heavier gas, more denser, less speed. This is the effect of density in the case of speed of sound. At constant temperature, the speed or V is independent of delta P. What do you mean by that? With the increase of pressure, density also increases. With the decrease of pressure, density also decreases. On the whole, P by D value is constant at constant temperature. Means according to Boyle's law, as long as the temperature is kept constant, P by D is constant. So, we can say with the increase of pressure, density also increase, with the decrease of pressure, density also decrease, but on the whole, P by D is constant. Therefore, there is no effect of pressure on the speed of sound at constant temperature. Now, effect of temperature. We have the formula V is equal to gamma P by D. We know from ideal gas equation PV is equivalent to RT for 1 mole of gas. From this relation we can say P and T, P proportional to T, where T is called absolute temperature, where P is the pressure of a gas. So, from this relation V and P, V proportional to root P and P proportional to T. Therefore, indirectly V proportional to root T. That means speed of sound increases with the increase of temperature. Now, let us see V0 speed of sound at 0 degrees, Vt speed of sound at T degrees. Now, from this relation V1 by V2 is equivalent to under root of T1 by T2. Now V1 means speed of sound at 0 degrees, V2 speed of sound at T degrees. 0 Celsius is equivalent to 273 Kelvin. So 273 by T degrees Celsius is nothing but 273 plus small t. So from this relation we can obtain V0 by Vt is equivalent to 273 by 273 plus t whole power 1 by 2. This can be simplified as Vt by V0 is equivalent to 273 plus small t by 273 power 1 by 2, which is equivalent to 1 plus small t by 273 power 1 by 2. Using binomial expansion, this V0 is V0, 1 is 1, 1 by 2 comes or is the factor over here, 1 by 2 into t by 273, and the whole after simplification of this, Vt is equal to V0 into 1 plus t by 546. With this simplification we can say, for the small variation of temperature, for every rise of 1 degree centigrade temperature, the speed of sound increases by 0.61 meters per second or 61 centimeters per second. Therefore, for the small variation of temperature, we can use that value for every rise of 1 degree centigrade temperature, speed of sound increases by 61 centimeters per second or 0.61 meter per second can be used. So, effect of humidity. As the humidity increases, density decreases and hence speed of sound also increases. So, with this expression we can say velocity, speed of sound through moist air is more than the dry air. That means speed of sound on the rainy day is greater than speed of sound through dry air is less when you compare with this one. So, we know that speed y value, n value, k value means elastic constants through solids, liquids, gases, this is a relation. So, with this relation we can say speed of sound is through more through solids, then liquids, then gases. Now, finally, we will see one more concept here. When gases are mixed together, suppose two gases are mixed with the moles N1, N2 are the number of moles of two gases whose molecular weights are M1, M2. Then we know V is equal to gamma P by D. Now, V of the mixer is gamma RT by M. In place of gamma, gamma mixer, in place of M mixer. So, where gamma mixer is the gamma is the ratio of two specific heat. Gamma mixer means Cp mixer by Cv mixer. Cp means specific heat of a gas at constant pressure and Cv is at constant volume. Now, mass M is called molecular weight of the mixer is equal to N1 M1 plus N2 M2 by N1 plus N2, where N1 N2 number of moles, M1 M2 molecular weights, where gamma mixer is Cp by Cv of mixer. Now, Cv mixer means N1 Cv1, N2 Cv2 by N1 plus N2. This is the formula for Cv mixer. We know Cp minus Cv is equal to R. So, Cp mixer is equivalent to Cv mixer plus R. So, finally, this is the formula to find out the speed of sound through gas which contain two or more number of gases.